Let me see if you can.
That's my fucking profile.
Hello, I'm just here to help. Let me know if there's anything you guys need.
Pranjali just asked, is it possible to have a background?
I'm not certain if it is in Hopin. I don't think you are able
Certified
to.
insurance voice.
Hello, everyone. Oh, okay. So that I can't really start my video unless I can add a background to this. Looking for that.
It's fine. It's fine. As long as you can speak. So let me see. How do I share my screen? This. Right. All right. Can you see my screen? Can you see my screen? Hello guys, can you see my screen?
Yeah.
All right. So how do you want to do it? You want me to just flip through the slides and you just tell me when to flip, or?
Yeah, I mean, so the only thing like that's really long is the code slide for the example. So that's the one that I guess I'll kind of have to like give you a cue on or something. But the others, yeah, just move the slide when like you think I'm almost over like explaining.
Okay. All right, you can still see it here, right? You can see it?
Yes, we're able to.
All right. And it's full screen.
Correct. Yes, it's in presenter mode right now.
Oh, Nick, I'll get them the rows.
Jose M.
You don't need to have your camera on for Jolly. You don't need to have your camera on.
Okay, I mean, I kind of fixed the camera, so that's why I thought I should like.
I mean, it looks like you're in a pretty busy room, so you don't need to if you don't want to.
Oh, okay.
Right.
But yeah, hi Adrian. Haven't seen you in a while.
Hello again. Yeah,
Right now.
I've actually.
Answering
Yeah,
all-
I thought I wasn't sure if it was you at first, but yes, it is.
Yeah, I mean, so the day I came back from startup, I ran into the Google Developer Student Club guys, and yeah.
That's really
You want me
cool.
to make it?
Huh?
That's really cool. No, I'm glad to see you involved too.
Yeah, I'm making it right now.
Yeah, it was a good opportunity. But yeah.
Okay. Sorry if there were some background conversations. I was still in Discord. I just left, so should be okay now.
It's fine. It's fine.
So one thing I was worried about is the speaker note. So for the code slide, it's really long. Like all my speaker notes are like good paragraphs. So I don't know how that shows up.
It doesn't show up. When you're presenting, it doesn't show up.
So I'll have to like read it on my own, like from my computer.
Yeah, probably. Good thing I'm the one sharing, so you can just read off that if you want to.
Okay.
All right, Adrian, should we wait like 2 minutes for more people to come in, like after 11 comes, or do we just start immediately?
You're able to wait a little bit if you don't think it's gonna, if like you don't think you would need that extra like maybe 5 minutes or so. Like I think it should be fine. That's what it's been like for a lot of them that we've been having. We just wait a little bit to let the people from the previous workshops to join the new ones. But yeah, you can give a couple minutes just to let people join, and then yeah, you can go ahead and get started afterwards.
All right, thanks.
And then in terms of what you would like me to do for the past couple ones, just to make it easier, I've been like reading off certain questions that people have in the chat. Is that something that you would like me to do? Just so you don't have to switch back and forth between the presentation and the chat.
Yeah, so I'm gonna stop. Well, we're gonna stop in certain sections, and we're gonna ask, is everyone following along? Are there any questions? And you can just read them off at those moments.
Okay, sounds good. Thank you.
Is there a power key for unmuting myself? All right, for everyone that's in here already, we're going to be waiting until 11:05 for other people to hop off their other workshops and pile in before we start. So everyone, if you're just joining now, we're going to wait until 11:05 for people to stream in from other workshops. Then we'll get started. All right, let's start sharing my screen.
So hello everyone. Welcome to our workshop, Intro to Tensorflow. So we're going to be showing you what Tensorflow is, what you can do with it, its purpose, and then some applications in computer vision. It's going to be a live coding session by David. My name is Pranjali, and that's David Janio. We're both tech leads at the Google Developer Student Clubs at FIU. And you guys should definitely take a look into that if you're at this workshop.
All right, thank you, Pranjali.
So as an intro, we're going to be going over machine learning in brief, what TensorFlow is, why is it called TensorFlow, installing TensorFlow on your local computer, and then an example of a basic neural network, then brief computer vision description, and then live coding session by David. So machine learning in less than 10 minutes is a really, really condensed overview. So machine learning, I mean, I don't want to read off the slides, but basically it's a subset of AI focused on using math to mimic human intelligence. What you're trying to do is see if a computer can make the same decisions a human does, classify things the same way, label things the same way a human does. Accomplish tasks that can be solved through traditional programming. So we have kind of like graphic description of what traditional program is versus what machine learning is. So in traditional programming, you just tell the computer certain rules and how to manipulate the data to get certain answers. And so in machine learning, you're actually feeding it answers and the questions together, and it makes the rules itself. So it's learned in a way how to deal with further data. You're not hard coding it, which is what like another word for traditional programming. Automate tasks that were originally done by traditional programming. So, originally done by humans. In fact, if a human, so in a factory, a human's trying to tell if a certain product is defected or not. Instead, you could use a machine learning algorithm that just takes pictures of that product and makes the decisions right then and there, and cleans off a company's product line and takes the defects out. So that's one quick example of how machine learning is being applied in today's world. So today we're looking into computer vision, and so we're going to be putting in using a data set, feeding it into an ML model that we're going to create, a sequential ML model with Keras under TensorFlow. The ML model is going to learn patterns among the data to decide what the answers to our questions are. So let's say we're asking it whether, so like a very basic example of how we introduce beginners to ML is a computer should decide whether a picture is a cat or a dog. So it identifies patterns in those pictures that tell it whether it's a cat or a dog. Patterns, edges, features. Tasks can be descriptive, predictive, or prescriptive. So computer vision is more of a predictive task. You're trying to tell what it is, what it's not. So and then so these are the three different types of types of tasks that a machine learning algorithm can perform, and three different ways the machine learning algorithm can learn or apply itself to the data is supervised, unsupervised, and reinforcement learning. More like a deeper description of that will be later in the presentation. And it's often associated with natural language processing, which is basically machine learning algorithms for texts, and then neural networks, deep learning, and computer vision, which is what we're doing today, image recognition, etc. So what is TensorFlow and why are we talking about it? So it's a library of functions. It's an AVML. It's the main library that we use in computer vision specifically. It makes data representation, so converting so you have an image. How do you convert that to something that's readable by a computer? How do you convert that to numbers? So TensorFlow lets you explore that. Then building the model through APIs inside TensorFlow. So these APIs, we have Keras, which is a sequential model. It's kind of like for mid-level models, in terms of complexity. So mid-level complexity that you've got. Then we've got estimators that themselves apply different types of machine learning algorithms to the data you feed it. So those are a very like high level complexity of machine learning algorithms. Today we're talking about Keras specifically in the live coding session. You can access TensorFlow. You can use TensorFlow through 3 different languages: Python, Java, C++. Most commonly used is Python. And if you guys really want to get into AVML, then you should probably focus on learning Python. And so, what is a tensor? So, if anyone's taken linear algebra or just knows what scalars and vectors are from physics, a tensor is like a representation of data in different dimensions. So, scalar, 0 dimensions. You've got just a magnitude. Then vectors, 2 dimensions. Got 1 and 2. So, a rank 1 tensor is a scalar. Rank 2 tensor is a vector. Rank 3 tensor is a matrix. And then combinations of matrices or combinations of vectors and finding relationships between them is what like kind of the TensorFlow name came from. So finding relationships, mapping different vectors to different vectors. Yeah. Installing TensorFlow. So please go to Google Colab. Just look up Google Colab on your computers. You should just be able to. So TensorFlow, I think that you need to install that. The code over here, you install that in your local computer. But Google Colab is somewhere that even if you don't have the software installed, you can still run Python and use all these libraries. So this is like the code on the left is for your local computer. So if you want to use a Jupyter notebook, for example, if you guys have heard of that, which is only for your local computer, which is only for like when you're trying to run, you need to install all these different module software. So if you put that in your terminal, it's going to install that into your computer, and then you can use it on Jupyter notebook. Google Colab, don't need anything. Straight up go there, and it's like a drive, like Google Drive for Jupyter notebooks. Kind of think of it that way. So yeah, please go to Google Colab because that's where the majority of our coding is going to be, and you can test things out for yourself.
Yeah, guys, I can't recommend Google Colab enough, especially if you're new to ML. If you want to do the mistakes, you want to do it in an environment where the mistakes don't really matter that much. But if you have TensorFlow on your local machine, and if you make a mistake, you screw around with your GPU trying to do GPU stuff, you could seriously mess up your computer. So definitely do it on Google Colab. We're going to be using that for the live coding session, so I'll show you how it works later.
Yeah, I mean, so one really cool thing about Google Colab is that when you make an error, it gives you like a link to Stack Overflow right under it. So you don't even have to do that. So yes, Google Colab all the way if you're just starting with machine learning. Jupyter Notebook goes into when you're doing, let's say you're doing like high level research where you want to, like if you're doing it for a company or something, I don't know, then you're going to use Jupyter. But Google Colab it's a really good way to not mess up your computer and do everything in a low stakes environment. So right here we have like a snippet of code in a Google Colab notebook. So here, like if you want me to give you like a brief explanation of what the code is over here, we're just importing NumPy. So NumPy is a library in Python, which is used for manipulating arrays, representing arrays numbers, and doing functions on that. And we're importing TensorFlow itself. So yeah, and then the version, tf.version or version gives you the command for finding the version of your TensorFlow, which is 2.6. I think that's the latest one. So as I told you, and NumPy is library for arrays. So we have like a little description of that in the very last line. And yeah, it defines arrays for you. That's it.
All right, and you'll notice that when we actually run stuff like this, where we're not actually printing it out because the notebook already does that for you. It prints out. So if we were to put "Hello World" just a string, it would just echo it in the output. That's really good for seeing what's in your variables and basically just seeing step by step what's going on in your code.
Yeah, exactly. So like a coding terminal right under your code. So that's something really good. Yeah. Okay, move on. So now we're gonna do like a brief example of a neural network, and this is where like things get like a little mathy. So you need to, so it's like a fun little pun. You need to draw a line somewhere. So what we're trying to do over here is linear regression today. We have an array of x's and an array of y's, and what we're trying to do is map these x's to these y's. And find like the linear equation that connects these two arrays. So f of x equals w times x. So why are we using w? Why not m? Like, you know, when we're doing math. So that's how we describe neural networks in machine learning. So over here I have like a little graph for you. So you have an input, which is you know, the x. It takes in that node takes in input values. Multiplies that by a weight, which is kind of like when you write y equals mx plus b, that represents your m, which is what you're like multiplying your x by. Then you add a bias. So the value of that node is 1 because you're just adding the bias by itself. It's a constant. You're not really like multiplying it with anything else. So a bias is a constant value that you add to get your final y value. And so y equals wx plus b is your output. And w and b, weights and bias, they're both known as parameters in a neural network. And this is like a very basic form. So what you might call a one-layer neural network, where you just have one weight, one bias, and one input and output mapping. So next, we're going to look at code and how this is actually represented in Python. So please don't be intimidated by this. I'm going to go through this line by line. So this was on a Jupyter notebook, but the same code works on Google Colab. Import Tensorflow STF, import NumPy, all these libraries. So Keras is an API under Tensorflow that you use to create sequential models. So from tensorflow.keras, you're importing sequential, which is what you use to create a layered neural network. Then from tensorflow.keras.layers, which is an API under Keras, import dense. So density, so this is what happens in neural networks. You can increase and decrease the density of your model, which has a direct impact on its accuracy and its runtime. So what we're trying to do here is we define a model with 1 unit, and it has a it has size of 1, which is just one node with 1 weight and 1 bias. So the optimizer, so this is where we're kind of gonna apply some high level math, but like a brief description of what we're gonna do. Give me a second. I'm trying to find where my link is. Okay. So if you've done anything with machine learning before, you're probably seen that it involves a lot of math. And if you haven't in calculus in years, it might have seemed like a barrier to entry, but here's the part where the math comes in. It's the core to machine learning. In a scenario like this one, the computer has no idea what the relationship between x and y is, so it's going to make a guess. So, for example, it guesses that, y equals 10x plus 10, so 10 weight, 10 bias. It needs to measure how good or bad that guess is, and that's the job of the loss function. So loss mean squared error. What mean squared error means is it's going to take the accurate y value for the given x, and it's going to subtract what the model thinks the y value is, and then square that. So it's going to take the difference between the right value, the correct value, and what the model's predicted, and square that value. So and then whatever the loss value you get, it's going to put that into the optimizer. So that's the job of the optimizer. The computer keeps making guesses and plugs that into the optimizer, and that's where the heavy calculus is used. But with TensorFlow, that's hidden from you. You don't really see what's happening behind the scenes. You can just pick like the appropriate optimizer to use for different scenarios. In this case, we picked one called SGD. It stands for Stochastic Gradient Descent. It's a complex function that when you give it values and the previous guess and the result of calculating the errors, which is the loss. So you give it loss, previous guess, and the accurate values. It generates another one, which is probably closer to the actual value. Over time, its job is to like minimize the loss, get closer to your given values, and by doing so, it brings the guessed formula closer to the correct answer. So I just explained STD and music writer, which were literally the most like the kind of like longest parts of this session. So next we're just formatting our numbers into the data format that the layers expect. So we're using NumPy, as I said, so it's a library that we use in Python to represent arrays. So we have an array of x's and y's, and data type is float. So just formatting that, putting our numbers into a NumPy array to make it easy to process them in x's and y's. The actual learning process is going to begin now, which is with the model.fit command, which you see right after the NumPy arrays. It's basically fitting the x's to the y's and trying it 500 times. I read that as 100, but yeah, it's 500 times. And these are titled as epoch. So the number of times you're calculating loss, you're putting into optimizer, you're guessing a new function. So it's doing that same process over and over again for 500 times. And over time, the guess is obviously going to get better. And then we obviously printed what it thought for number 10. So before I go into what it predicted, let's look at the right side, so which is the epochs themselves. It's running them 500 times. It starts with 1 and 2 and goes all the way until 500. So as you can see, in the very beginning, its loss was like 3.2868 from the actual value, like how far away it was. And then as you look, so I kind of gave you like the first 5 and then the last 5. So when you look at the very last epoch 500, you can see that the loss is like really, really small. It's like 2.6 times 10 to the negative 5. So completely negligible. That's what you get as like you run more times, the loss is going to keep going down for you with the help of the optimizer function. And so what we've done over here, like the last 2 lines to test what the model's capabilities are, we just printed what it thought for 10. I don't have that value here, but on my computer it came around 19.8999, something very close. Sorry, not 19, 8. It was 18.0001. Kind of read that wrong. So 18.001. Wait. No, it is supposed to be 19. It is supposed to be 19. I don't know why I'm doing that, but yeah, it's supposed to be 19. If you guys haven't already like kind of thought about what the relationship might be, it's just 2x minus 1 from the x to the y. We're multiplying the x's by 2 and subtracting 1 to get the y values. And what I tried to do was try to print what the parameters were at the end of running this entire model. And so that's why I used this command print. Here's what I learned, and then format its weights. So format its weights, so format its weight and bias both. So that's what it printed out, the very last line over here. Here's what I learned. It gives you 1.9967 for the weight, and then for the bias, it gives you negative 0.99. So 2x minus 1 kind of approximate that to those values, super close. So y equals 2x minus 1. Yeah, so that was the function, and that was like a kind of basic intro into how neural networks work and linear regression neural networks. So yeah, David, take it away.
All right, thank you, Punjali. So now that we've gone over like a very brief explanation of what ML is, and you've seen TensorFlow, hopefully you've opened up Google Colab and you've browsed through there. We've showed you an example of using TensorFlow. Are there any questions at this moment? Adrian, if you could please let me know if there are any questions.
Definitely. Yeah, there aren't any at the moment, no. Doesn't seem like anyone has any. But
right.
If anyone does have any, I'll let you know.
All right, thank you. It looks like the neural network workshop was really good. All right, so let's get into computer vision. So as we mentioned before, ML, you're trying to get data into a model so that the model can learn patterns in that data, and then you can predict with that data. So the data now that we're going to be using is pictures, and the data in pictures are pixels. So for grayscale pictures, it's going to be values from 0 to 225 to 55. I mean, for every pixel, that's from 0 black to 255, which is white. For colored pictures, it's going to be a tuple or a list of 3 values, which is going to be the RGB values, red, green, blue. And it's going to go from 000, which is black, to 255, 255, 255, which is white. And any variation between that is just more hued of green, red, or blue. So it's possible to represent these pictures as tensors or arrays and matrices to the model. And I'll show you that later in the code. So what is our main tool for image recognition or computer vision? That would be convolutional neural networks. So these are special deep neural networks designed to find patterns in an input image, such as lines, gradients, circles, even eyes and faces. So basically features of the picture. And it isolates these features in images in order to predict what is in the picture. It's usually accompanied by a pooling layer to help extract the dominant features. So here is an example of an ML model with a CNN and some pooling layers, and then a neural network to get the predictions. It's going to be 10 classes. So there's 10 things a picture could be in this model. And from what it looks like, it's the handwritten number. So it could go from 1 to 9. So let's get this 2. We have our convolutional neural network right here. It's going to get the features of this number 2. Probably like, oh yeah, there's a curve here. There's like a circle in the middle. There's this hook or whatever here. And then that's going to be in our convolutional neural network. That's going to be a filter or a feature there. Our max pooling, it's going to say, all right, enhance on these features. This is what we're looking for if we want to get the number 2. And then we want to do another convolution on these enhanced features to get even more features out of these features. And then we're going to do the max pooling again to enhance it again. And now we're going to flatten it. Neural networks do not deal with data above the vector. So we need to turn our feature array here into a vector and then feed it into a neural network where it will learn patterns based on those features that are passed in to predict whether it's 1, 2, 3, 4, all the way to 9. All right, are there any questions on that?
So far, no.
All right. Okay. So let's get into the code. I'm going to be showing you 3 ways to make an image recognition model or a computer vision model. We're going to see it from scratch with a neural network, from scratch with a convolutional neural network, and then from scratch with a convolutional neural network and a data generator. And this is probably what you're going to be doing if you're going to be doing an image recognition model for your hackathon project. All right, so let's get into it. Pranjali, if you could please share the link to the first one in the chat for me, please. All right, here's Google Colab, as we've seen before. It has slides, it's a notebook, very, very intuitive. We're going to import our libraries, NumPy, TensorFlow, Matplotlib, and random. We're going to see what version of TensorFlow we're running. 2.6, awesome. And now we're going to load in a a TensorFlow data set called the MNIST handwritten numbers data set. So this is a data set of 60,000 handwritten numbers in grayscale. They're 28 by 28 pixels, and the one just signifies it's in grayscale. So let's load that in. We're going to have X-train. We're going to have two different types of data here. We're going to have the data we're going to use to train the model, and we're going to have the data that we're going to use to test the model or evaluate how much the model has learned. We have to keep them separate because if the test data leaks into the train, you'll get really bad results when you're, or misleading results when you're evaluating your model. Now we're going to divide all the values by 255. The reason we do this, divide by 255, this is the max value the pixel can be. The reason we do this is because neural networks do not like numbers that are very spread out. So we need to scale them down to around like 0 to 1 range so that the neural network doesn't freak out and explode. And let me show you the shape of our data. For our training data, we have 60,000 28 by 28 pixel handwritten numbers. And for our test data, we have 10,000 28 by 28 pixel handwritten numbers. All right. So now let's show with Matplotlib some of the images that we're going to be working with here. See, handwritten numbers, kind of ugly, but it is what it is. I have ugly handwriting too. I'll run it again, get some different numbers. All right. And now it's time to make a neural network. So as we said before, we're going to be using a sequential model. It is basically the layer by layer model that you see all the time everywhere. So we're going to have our first layer here, our flattened layer. This is to make the 28 by 28 because neural networks don't deal with higher dimensionality than vectors, remember? We're going to flatten it out to make it a vector. We're going to pass it into this dense layer right here. This is going to be our first hidden layer and our only hidden layer. And this is where the math is going to happen to find the patterns and stuff. We're going to have a dropout layer here. What this basically does is,
Oh, no, sorry. I just got disconnected in the middle, so I was just typing. Sorry. Just never mind.
All right. So the dropout layer here, this is basically to prevent overfitting. And overfitting is basically when your model gets too comfortable with the training data and can only predict on the training data and can't predict on anything else. And that's really bad because you want your model to predict on stuff it hasn't seen before. And we have our dense layer with the softmax. And this is going to basically give a list of probabilities on what number it is. So an example of what this would look like would be, say, 2, 3. Let's say we're trying to predict, whoops. I'm not running this. Oh, I did run this. Let's say we had 3 instead of 10, so I don't have to write that much. Softmax result would be something like 0.2, 0.3, and 0.95. 0.2 would be the probability of the number being predicted of being a 1. 0.3 would be the probability of it being a 2. And 0.95 would be the probability of it being a 3. And that's generally what it would look like. So here we can see our model summary. You can see the number of parameters. That's a lot of parameters or weights that are going to be changed. and that's where our patterns are going to be. We're going to initialize the model, optimize our loss metrics. We're going to be using a different optimizer and loss here. So the optimizer is what's going to be basically fixing up the model depending on the loss. And the loss is basically going to be telling our model, hey, this is how bad you are right now. And the optimizer is going to look at that loss and say, all right, this is what we need to fix. Here, fix it. And we're going to be tracking the accuracy of the model. All right. Now time to train. Let me put 5 epochs, so it shouldn't be that long. It's already in the 90s in terms of accuracy. That's very good. The handwritten numbers data set is actually pretty easy data. So that's to be expected. Now we're going to evaluate on our test data, and we'll see that the loss is very low and the accuracy is very high. So we're happy with this. All right. Any questions?
None that I can see.
Dang, that neural network workshop was really good then. All right. Let's see. All right. Now we're going to be reshaping our training and test data sets. We need to do this because for the convolutional neural network layers, Keras expects a certain type of format for our data, and that is -1, 2821. It's going to be this for. Can you please mute yourself, Adrian, please? Thank you.
I apologize.
All right, so let's get into our CNN model. It's going to be the same as the other. It's going to be sequential, the layer by layer. We're going to have our convolutional 2D with a depth of 32. Our kernel is going to be 3 by 3, so it's going to be looking at 3 by 3 pixels. And our activation ReLU, and our input shape is going to be 28 by 28 pixels in grayscale. We're going to have our max pooling 2D to accentuate those dominant features, flatten it out to get a nice vector, then run this cell. And then we're going to have our dropout layer to prevent overfitting, and our dense layer with a soft max activation to get the probability of it being whatever number. Let's see a summary of this. It's very similar to the neural network, right? Because it's the same model type. All right. Now we're going to get it ready for training. We're going to be using the same optimizer and loss. And let's train the model. So as this is training, you're going to see that it gets around the same in terms of accuracy. But like I said before, that's mostly because the handwritten numbers data set is actually a pretty easy data set for these neural network and CNN models. So it's not really an accurate representation of how good a CNN model is compared to a neural network. So the next step after this is done training, and you'll see the evaluation of it on the test data, I'm going to actually change up the data set to colored images, and then you'll see how much better a CNN model is compared to the neural network. All right. These usually take a lot longer to learn, to train, because they're deep neural networks. So it's a lot more weights that need to be changed in the neural network or in the network itself. So it takes longer. And the bigger or more complex the data set you have, the more data you need. So if you were to use this and say you only have like 10 images, this will be kind of overkill. So definitely keep that in mind if you're going to be doing an image recognition project for this hackathon. You don't want to do this if you're really time constrained. There's not a last minute thing to do. Something unexpected could happen. You're training, maybe it could take 5 minutes. Maybe it could take an hour. Who knows, depending on how complex you make it, how much data you have. All right. Training is done. Let's evaluate it. Pretty high, a little bit higher than the neural network, but not that big of a difference, right? All right. Now let's change the data and see how much it changes. So before we had our handwritten numbers. Now in grayscale, whoops, did that by mistake. Now we're gonna have colored, not handwritten numbers. Gonna do the division again to down. The shape is different this time. Instead of in 1 for grayscale, it's 3 because you got the RGB values, right? Training, you got testing. Let's show some of the pictures that we'll be working with. Kind of different. You see cats, trucks, cars, birds, I guess, dogs, animals, I guess. So it's a lot different, colored, kind of low quality, but it is what it is. We need to change our model now. We need to change it from a 28 by 28 input to a 32 by 32 by 3. 32, so these pictures are 32 by 32 pixels, 3 channels RGB. I already went over this, but the dense, you got the dropout, you got another dense, there's a softmax, which is going to be the probability that it's either a bird, a plane, or whatever. Have a summary right here. It's a bit bigger. It kind of tripled in size there, but we'll see how it does. Same compilation, and now let's train it. Now you're going to see where the deficiency of a neural network kind of lies in terms of image, working with images. It kind of blows because it's not trying to get any features. It's just only working with the pixels, with the pixel values here. So imagine trying to predict whether this is a bird or a plane or a car. When you get pixels like right over here, it's kind of hard. So as you can see, our accuracy, 31%. That's pretty horrible. Let's evaluate it on the test. 37%. I mean, you can flip a coin and have better odds than that. Or maybe even a 20-sided die. All right. Time to change the data a bit. We need to reshape it because convolutional neural networks, they like a different type of data form and ends. We got our -1, 32 by 32 pixels, 3 channels, RGB. Remember, we're going to change our layer over here. So that I can accept 32 by 32. Pretty much the same. And you can see it's a little bit less parameters than the neural network. Same compile, initializing, we're going to fit. As this thing trains, you'll see that it kind of really surpasses the neural network almost immediately. And that's kind of the magic of a CNN. It's learning the features of these pictures up here. So instead of just working with the pixel values, it's looking at, oh yeah, there's like windows over here, there's headlights, there's wheels. All right, this is probably a vehicle. there's an animal. It kind of has like a round shape, has colors, fur, feathers. This is probably an animal. I don't know. Probably for this, they'll look at the wheels and the windows as well to see that's a vehicle. Animal. And there was pictures of planes as well in this data set. Let me see if I can find some here. Oh. Whoops, I forgot that I need to wait for it to finish training. Well, anyway, there's some pictures of planes in here, and probably the features it would get for that would be like the lines of the wings, maybe even the cone shape of the front of the airplane. And it would get that. All right, it's almost at 50% now, and this is a lot better than the neural network, especially with less parameters. This is almost, let me see. Oh yeah, almost 100,000 parameters less. Still takes a while to train though, because the convolutional neural networks themselves are basically just deep neural networks. All right. Coming up on the last epoch. And after this is done, and you'll see how superior CNNs are, we're going to go into a more sophisticated example. And I'm sorry that I'm going to have to go pretty fast through it. But what I'm going to show you next is probably what you're going to be doing if you're doing an image recognition model for this hackathon. All right, coming up on the end. 3, 2, 1. All right, accuracy. All right, 56%. Pretty good. All right. As you can see, CNN's superior to NN's, all right, for image recognition, computer vision tasks. All right, to the next one. Pranjali, if you could please send in the second link into the chat for everyone. So here's what's going to happen. We're going to be downloading a bunch of pictures of cats and dogs. Now, this isn't going to be exactly the same as a Kaggle data set. It's not going to be organized. It's just going to be two directories, one for cats and one for dogs. And our task is to structure or create directories for an image data generator here. And this data generator, is going to stream in the data and make some modifications to it as well. So you get even more data and basically not explode your RAM in the meantime. All right, so let's import our libraries. Again, I'm running out of time, so this is going to be pretty fast. My apologies. Hopefully you can go slowly through this collab later. We're going to extract, we're going to download the zip file with the cats and dogs. We're going to put it locally in a temp directory, and we're going to open it. Show you that directory in the actual collab itself. You go to this folder icon right here, and you go up a level. You would go all the way down here to temp, where you would get to see the data. It's done downloading, and here's our pet images. We're gonna have cats and dogs, and inside these directories, it's just a bunch of images. So how many images? 1,501 for each. Now let's make some directories for our image data generator. Oops. Refresh that temp. Here's our cats and dogs. We're going to have a testing and a training directory. We're going to have cats and dog images here. Our image generator is going to get the pictures from each of these and kind of feed it into our model. So let's make a function. This is just to split out the data from the source with all the pictures into our directories. I can't go step by step because I'm running out of time. So now that it's done, we're gonna have a bunch of cat images here, cats and dogs here. Split. So it's gonna be, the split size is gonna be 0.9. It basically means 90% of the data in the original is going into the training and 10% is going into the testing. Right. Go fast. Here's our model. It's a little bigger, more complex. And the only difference here is that we're going to be using a sigmoid activation here because we only have 2 classes that it could be. So it's going to be either 0 or 1. And this activation makes it so that it's between 0 and 1. We're going to be using binary cross entropy for our loss. So before we were using sparse categorical cross entropy, that's for more than 2 class labels. But since it's only cat or dog, we're going to be using binary cross entropy. We're going to have an optimizer here, is what's going to fix our model. And we're going to keep track of accuracy. All right. So here's where our image data generators come into play. So what do these do? They create a stream of data into your model. All right. That's the best definition I can give. So we're going to initialize it here. This is kind of what we did with our images in the other collab. We're rescaling all the values by 255. And now we're going to initialize our stream. We're going to get the training there where the training images are. We're going to resize all the images so that they're all the same size to 150 by 150. Our batch size is going to be 20. There's like an equation to get this batch size, but I'm not going to go over it right now. And our class mode is going to be binary, so it's either cat or dog. We're going to do this with our validation as well. Our validation is basically the data that's going to be tested while the model's training to make sure that the model isn't overfitting to the training data. All right. And now we're going to fit in our train generator. So it's going to be our stream in 15 epochs. And for our validation data, we're going to have the validation generator. So we have 2 streams here, one for the training and one for the validation. Now, I'm not going to press play on this because it took like 40 minutes to train. It was a pretty big model, so I'm not going to do it. But in the end, it comes out to a pretty decent accuracy of 87%. And here we can see some graphs on the validation and accuracy and training accuracy, as well as the training and validation loss. It's pretty together, so it's kind of really good. This is what you want to see. All right. That was really fast, but in order to finish, I need to go into the next steps. So after you have your model, you need to save your model in order to use it. And there's 2 ways you can do it from what I know. Maybe there's other ways that you can find out there. You can use Tensorflow serving, which basically it's a Tensorflow service to basically use your model as an API locally, like a REST API. Or you can use this method I found in towardsdatascience.com, where you can have your model in a Docker image with Tensorflow and then create an API around that Docker image to query from that model. I'll put this in the chat for you guys. All right. And that's pretty much it. There's 5 minutes left. Last thing I want to say, please join us. Join us at Google Developer Student Clubs. We'd love to have you. You could either join from the link I'm about to send or from the QR code on your screen. All right.
So yeah, guys, thank you so much for coming in to the workshop and listening to me and David talk about TensorFlow and building models. And yeah, please look into Google Developer Student Clubs. Like we're almost 700 people now. And everything's on the Discord server. Find your community, find what you want to learn. We have a bunch of different, we have tech leads that have expertise in different topics, competitive programming and then AI. And yeah,
All right. Are there any questions before we end this workshop? I know I went a little bit fast, but hopefully you got the collab links. Any questions?
Doesn't seem like it, no.
Man, this must have been a really good workshop then.
yeah.
All right.
Yeah.
All right. Hopefully you guys learned a lot. It was definitely a lot to take in. If we went into the math, this probably would have been like a free code camp, 12-hour long workshop. So yeah, it was very fast. It's a lot of information. Hopefully you guys join Google Developer Student Clubs and you can. All right, thank you, Jacob.
Thank you, everyone, for coming, and thank you, David and Sanjali, for presenting this. Thank you, guys.
You're welcome.
You're welcome.
All right. All right. If there are any questions, put them in the chat. You have 3 minutes left. It was very high level, but there was no other way if we wanted to fit it into the 1 hour time span.
Yeah, and if you want to actually like, if you want to deploy it, like, and actually use it in the hackathon, then I guess this workshop should have helped you just kind of get an idea of what it's like to build models on the run if you want to get something done.
Right. 2 minutes left. Any questions? Did you guys see that link I sent for the Discord? Where our main chat is. You can chat with me, Panjali, about this. Ask questions.
Yeah, reach out to us on Discord. I think we did share our ads at the very beginning. Yeah.
Didn't see them.
I'll just add it in the chat if you want to reach out to me or David. So. Sorry, mine's wrong. I need to just fix that. There.
All right, good session. Hopefully you guys learned a lot. Coming up on the final minute now. Final remarks?
No questions at all.
Join Google Developer Student Club. Join our developer community meetings if you want to learn more. Definitely more than happy to guide you guys in your journey of ML.
And reach out on LinkedIn if you can. I think that's where I'm kind of active a lot.
We should probably put our LinkedIn in the chat. Let's do that.
So here's Mhm.
All right, that's it. Thank you guys for coming. Adrian, how do we finish this?
So yeah, thank you everyone for coming. And the next workshops, if anyone is interested, there's one at Salesforce where the future works. It's from 12 to 1, and then there's also one from 12:30 to 1:30. It's cracking your Facebook coding interview. So those are the next workshops if you guys are interested. And yeah, thank you all for joining this one. I certainly learned a lot. Yeah, if there's any questions or anything like that, feel free to ask. Otherwise, I'm going to have to hop off so I can join one of the next sessions to help out.
Okay,
Alright.
so thank you for coming, guys. Again, and yeah, reach out.
All right. Goodbye, everyone. Thank you.
Bye.
Join
Thank
the
you.
Discord.